All right, so this is 7.4 matrices and systems of equations. So we're going to use matrices as another way on how to solve systems of equations, and we'll get to that in a minute. First thing we want to look at is our definition of a matrix. So a matrix is named by its rows and columns, so we say rows by columns. The rows come first, columns come second. And then when talking about a specific number in our matrix, we can use this, where the I is what row it's in, and the J is what column it's in. So if you look here, we have the first row, third column, so it would be 1, 3. In example 1, all we have to do is determine the dimension of each matrix, so we just have to say our rows by columns. So how many rows do we have in matrix, the first matrix in A? 1. And how many columns? 1 column. So it's a 1 by 1. In B, how many rows do we have?
1.
1. And how many columns?
1. No.
4.
4.
So it's a 1 by 4. In C, how many rows do we have?
2.
2. And how many columns?
2.
2. In D, how many rows? 3. And how many columns?
2.
2. And in E, how many rows?
3.
3 rows. And how many columns?
1.
1. So rows go sideways, side to side. Columns go up and down. Just think like when you go to a movie and you sit in one of the rows, you walk sideways. Next, we're going to be given a system of equations, and we take all of our coefficients in that system of equation and put it into our augmented matrix. So this here is an augmented matrix. We take the coefficients of our x's, our y's, and our z's, and then our answers. And we just put them into our matrix. So our matrix is just all the coefficients. We get rid of the x, the y, and the z, and the equal. Our coefficient matrix is just the coefficients of x, y, and z. So this is just x, y, and z. And our constant matrix is just the answers. So in example 2, it asks us to write the augmented matrix for the system of linear equations. So that is everything. We have to write our coefficients and our answer. So we start with our x's, our y's, our z's, and then the answers. So starting with the first column of x's, what numbers would we put there? So what's our coefficient for the first x? 1.
1.
What about the second one? Do we have an x in our second equation?
No.
So what do you think is going to go into our matrix? 0.
0.
Yep. And then the third column, the third row in the first column would be 1. Now let's move on to our y's. What would the coefficients be in our y column? 3. What's next? -1, because it's a negative y. And then what's next? 0. Perfect. And then the z's. What comes first?
0.
0, then
4.
4, and then?
-5.
Awesome. And then we just put our answers. So 9, -2, 0. What is the dimension of the augmented matrix? How many rows do we have? 3 rows. And how many columns? So it is a 3 by 4. Okay. So next, we're going to be solving some equations. So these are the steps we have to follow. We have to interchange. These are the steps we can follow. We can interchange 2 rows, multiply one of the rows by a non-zero constant, and add a multiple of one row to another row. Our goal is to get our matrix to look like this. We want this little triangle where we have this diagonal of ones and zeros below it. So this is our goal when solving our matrices. In example 3, it just asks us to do one step at a time. So in A, we have to interchange the first and second rows of the original matrix. So all we're doing is just switching the first and second row. So our new first row is what? If we just switch the first and second, what would our new first row be?
It would be the second one.
It would be the second one, which is?
Negative 1, 2, 0, 3.
Negative 1, 2, 0, 3. What's our new second row?
First one.
The first one. 0, 1, 3, 4. And then the third row stays the same. 2, negative 3, 4, and 1. So that is it for that one. For B, we have to multiply the first row of the original matrix by 1/2. So we're multiplying this whole row by 1/2. So what would our new first row be?
1, 2, or negative 2, 3, and 1. Negative 1.
Awesome. 1, negative 2, 3, and negative 1. And our second and third row just stays the same. We don't have to do anything to it. In C, we have to add negative 2 times the first row of the original matrix to the third. So we're multiplying negative 2 times row 1 and adding it to row 3. So let's multiply negative 2 to our first row, and what do we get?
Negative 2, negative 4, 8, and negative 6.
Perfect. And then our third row is 2, 1, 5, and negative 2, and we just have to add these together. So what do we get when we add them together?
Negative 3.
What's negative 2 plus 2?
0.
0. And then?
Negative 3.
Yes. And then?
13.
And then?
Negative 8.
Perfect. All right, in example 4, it's actually all worked out for us. It's just on the left side is our linear system, how we would solve it like we did in 7.3. The right side is our augmented matrix version of it. So this just takes our linear system and puts it into our augmented matrix form. And then it performs the same operations on the left side as it does on the right side. So it's already all worked out for us. And then if we take a look at the bottom, remember we said our goal was to get this diagonal of ones and zeros underneath it. If we compare our augmented matrix at the bottom to the system of equations on the left, we see that we have 3 variables, then 2 variables, then 1 variable. And at this point, we can use back substitution to figure out what our answer is. So that's why we want to get this diagonal of ones with zeros underneath. Because at that point, we can use back substitution, and it makes it a whole lot easier for us to solve. So we're going to use our matrix to solve this system of equations. So how can we put this into augmented matrix form? what would our first row be?
Negative 1, 1, negative 1.
Yes. Negative 1, 1, negative 1, and then negative 14. What would our second row be? 2, negative
2,
one,
negative 1,
1, 21. And then our third row? 3, 2, 1, 19. Awesome. So our goal is to get a diagonal of 1s and 0s underneath. So what do you think we have to do to the first row to get that top left number to be 1? It's already negative 1. What do we have to do to it?
Multiply by 2.
Multiply by negative 1, because that would give us a positive 1. So we're multiplying the whole first row by negative 1. So it becomes 1, 1, negative 1, 1, and 14. Perfect. Now we want to get this to be a 0. So we're going to have to combine two of our rows together to get that to be 0. So on the side over here, what operation do I have to do in order to combine two rows to get that 2 to be a 0? What would I have to multiply by the first row? So looking at our original first row here, what do I have to multiply? So 2 times row 1 plus row 2. So 2 times our original row 1 would be negative 2, 2, negative 2, and negative 28. Our row 2 is 2, negative 1, 1, and 21. And we just add these two rows together. So it's negative 2 plus 2? 0.
0.
What's 2 minus 1? 1. Negative 2 plus 1? Negative 1.
Negative 1.
And negative 28 plus 21? Negative 7. So 0, 1, negative 1, and negative 7. We have to do the same thing for our third row because we want this number to be a 0 also. So what can we multiply by our first row to get it to cancel out with that 3 and get a 0 there? What can we multiply here?
3.
3. Awesome. So we're going to multiply 3 by row 1 and add it to row 3. And I always write this on the side so I know what exactly I'm doing. So I don't get lost somewhere along the way and accidentally move on to row 2, go backwards, or something like that. So it's always good to just label what you're doing. So I'm multiplying row 1 by 3. So I have negative 3, 3, negative 3. And what's negative 14 times 3? Negative 42, and I'm adding that to my third row, which is 3, 2, 1, and 19. So what happens to the 3's? Negative 3 plus 3 is?
0.
0. 3 plus 2? 5. Negative 3 plus 1? Negative 2, and negative 42 plus 19? Negative 23. So that's my new third row. 0, 5, negative 2, and negative 23. So just a reminder, we want that diagonal ones and zeros underneath. So right now I have a good first column, and I have a 1 there. So I'm set up. Now I want this number to be 0 also. So what do you think I can do to get that 5 to become a 0? Which row? We could do that, but then if we add the first row to the second row, we would get, or the first row to the third row, we would get a 1 there, which we want to keep that 0. So we can multiply the second row by -5. So we have row 2 times -5 plus row 3. So our first row is staying the same. That's why I rewrote it. Yes? I have to add them together in order to get the zeros. So -5 times the second row would give me a what for my second row? 0. What would be next? -5. Next? 5. And then? -5 times -7? 35. And I'm adding that to row 3, which is 0, 5, -2, and -23. So 0 plus 0 is 0. -5 plus 5 is 0. -5 or +5 minus 2 is what? 3. And 35 minus 23? 12. So my new third row is 0, 0, 3, 12. So now I have my goal here, except that last 1 on the bottom. Remember, I want a diagonal of 1s with 0 underneath. So I need to make that 3 a 1. So what do you think I can do to the third row to turn that 3 into a 1? Anybody? What do you think? Awesome. I want to divide the third row by 3. So when I divide the third row by 3, I have to make sure I divide the 3 by 3 and the 12 by 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. So now I have my diagonal of 1s and 0s underneath. So that's exactly what I was looking for. Once I get here, I can plug it back into my system of equations and do back substitution. So I have x minus y plus z is equal to 14. Y minus z is equal to -7. And z is equal to 4. So just a reminder, these are your x's, these are your y's, these are your z's, these are your answers. Now we just use back substitution, plug in what we have. So z is equal to 4, we take that, plug it into z. So we have y minus 4 is equal to -7. How do we solve for y?
Just plug it in.
Well,
So
add 4.
plus 4
Yeah.
and plus
So y is equal to?
-3.
-3. So we got our y, and then how do we find z? X. How do we find x? We already have z. plug in the y and the z. So we have x minus negative 3 plus z, which is 4, is equal to 14. So x plus 3 plus 4 is equal to 14. X plus 7 equals 14. And what do we get for x? 7. So we would just write it as a coordinate triple, an ordered triple. So we have 7, negative 3, 4. That's our answer. So we're doing the same thing here. How would we put this into our augmented matrix? What would our first row be? 1, negative 2, 3, and 9. What's our second row? Perfect. And what's our third row? Awesome. So again, we want to get our diagonal of 1s and 0s underneath. We already have 1 in our first spot, so we're good to go. So next we want to try to get a 0 here. Oops. A 0 here. What can we do to get a 0 into that second row, first column spot? We can do what? We can just add row 1 to row 2. So we have 1, negative 2, 3, 9, negative 1, 3, 1, and negative 2. So our first row stays the same because we already have that 1 in that first spot. We're adding the first row and the second row to get that 0 in the second spot. So we have 0, 1, 4, 7. And then what can we do to get a 0 in that third row, first column, where that 2 is? What do we have to do to get a 0 here? We can multiply the second row by 2 and add it to the third row. So 2 times row 2 plus row 3. So 2 times row 2 would be negative 2, 6, 2, and negative 4. Row 3 is just 2, negative 5, 5, and 17. Add them together. So negative 2 plus 2 is 0. 6 minus 5 is 1. 2 plus 5 is 7. Negative 4 plus 17 is 13. So you have 0, 1, 7, 13. So next we have a row of 1s plus 1 here. So we want to get a 0 here in this spot. What can I do to get a 0 in that third row, second column? Can I multiply something by the second row and combine it with the third? Can I add these two rows together to get a 0 here?
No.
Why? Can I multiply something and then add it together?
-1.
Yes, let's multiply the second row by -1. So -1 times row 2 and add it to row 3. So -1 times row 2 would be 0, -1, -4, and -7. Row 3 is 0, 1, 7, 13. Add them together. We have 0, 0, 3, and 6. So 0, 0, 3, 6. So now we have 1's there, 0's below it, but we still need that 3 to be a 1. So what can we do to the 3 to turn it into a 1? Divide by 3. So we want to divide the whole third row by 3. So everything else stays the same above it. We have 1, -2, 3, 9, 0, 1, 4, 7. We're dividing the third row by 3. So it's now 0, 0, 1, 2. And now this is our new system of equations, and we can use back substitution to solve. So we have x minus 2y plus 3 is equal to 9. Y plus 4, z is equal to 7, and z is equal to 2. So we take z is equal to 2, plug it in to find y, plug y and z in to find x. So now we would have y plus 4 times 2, which is 8, is equal to 7. Subtract 8 on both sides. Y is equal to -1. Plug our y and z into the first equation. So we have x minus 2 times y, so this would be a plus 2, plus 3 times z, so plus 6, is equal to 9. X plus 8 is equal to 9. Subtract 8. X is equal to 1. So our answer is 1, -1,